Hello and welcome to our Seminar 1 for Team 50 and TP2 this semester. My name is Jesse. I'll be taking you through the first part of the hardware and the firmware interface. Rabi will be taking you through the second part of the hardware and the PCB designs. Jake will take you through the firmware and Tom the software. The first part is the voltage measurement. Nothing's really changed in terms of the overall design, however we've remapped it to 0 to 5 volts for the ADS 8866 and rebuilt with OPA 4197s. Which are rail-to-rail low offset voltage for greater accuracy. We've also implemented the auto ranging and some calibration with the ADC, as you can see in this video. Starting in the 1 volt range, into 5 volt range, 12 volt, and as you can see it's mapping quite closely with the actual voltage applied, which is always nice, and into over limit. Current is much the same, just measuring across a 1 ohm shunt resistor into the same back end of the circuit. With the OPA, we've actually been able to achieve a much linear curve than what we were previously, which is able to map quite nicely into firmware, as you'll be able to see in this video. Going to start in the 10 milliamp range, my apologies, and then you'll see it scale up into 200 milliamp range there. Now over limit. For the logic probe, what we've done is connect a negative voltage across a 1 meg resistor at the input to the voltage section. This is done through a relay which is controlled only when in logic mode. This allows us to put a negative voltage through the circuit which is not required for logic, and therefore we can test open circuit, and just using the voltage circuit we're able to detect high or low. As you can see here, as it thresholds to 0.6, goes low, and then disconnect. In terms of the overall design, we're just using a 4:1 mux on the front end to select the mode, and a mutually exclusive relay for resistance voltage to bypass the voltage divider for the resistance measurements for more accuracy. In terms of to do for hardware, I still have to look at input protection, some ADC protection, and the calibration with the PCB. Now I'm going to pass over to Rabia, and she's going to walk you through her part of the design.